In this video, I'm going to go over your Section 4.1 quiz or test. So please get that quiz out so as we go through it, you can make corrections on the ones that you missed. Okay, so the first 5 asked what quadrant the angle is in. If I were going to do a road map, pi would be 5 pi over 5. Half of that's about 2.5 pi over 5, so pi over 5 is definitely in quadrant 1. 7 pi over 4 is one that we're a little bit more familiar with because it's one that's going to be on our unit circle, but once we figure out that this is 6 pi over 4 and 8 pi over 4, this lives in quadrant 4. Negative 7 pi over 3. I'm going to build a negative road map. So I have negative 3 pi over 3 and negative 6 pi over 3. And then this would be half of negative 3. So I know that it's going to also live in quadrant 4. 268 degrees. Since we know that this is 270, 268 is just shy of that, so quadrant 3. And the last one, 554 degrees, if we go around 360 all the way, and then 360 plus 180 is 540, and we're going to be a little bit further, so that's going to be in quadrant 3. Okay, the next questions wanted you to sketch the angle, and that's where some students didn't do as good of a job sketching. I want to see the sketch of this angle. So if this is 6 pi over 6, all the way around is 12 pi over 6. So 5 pi over 6, or sorry, 12. I'm not sure why I'm doing it in 6s. But since this is in 12s, I'm going to do that road map the same way, but I'm going to do it in 12s. So this would be half of it, or 6 pi over 12. So this angle is going to be in quadrant 1. Okay, so this is 5 pi over 12. So that's what I'm looking for that sketch. Now all the way around is 24 pi over 12. So if I do the negative angle to meet that, don't know why I can't write 24, the negative angle to meet that would be 24 pi over 12 minus the 5 that's used up, so negative 19 pi over 12. Then I certainly don't want to go on that same grid because it's quite messy already. I'm going to go all the way around 24 plus 5 more to get 29 pi over 12. Now in the case of negative 3 pi over 7, I'm going to do a negative road map. Remember, 3.5 pi over 7 isn't a nice way to answer a question, but it's just our road map, so we can use that. I'm looking for this in terms of the sketch. Now if I want to find a positive angle, I'm going to do this, and that positive angle, I know all the way around is negative 14 pi over 7, or 14 pi over 7. I've used up 3, so I'm left with 11 pi over 7 in the positive direction. Now if I need another negative one, I'm going to go all the way around negative 14 plus negative 3 more, or negative 17 pi over 7. Now if the problem starts in radians, you keep it in radians. If the problem starts in degrees, you keep it in degrees. So negative 50 degrees, this is probably a little bit easier for us to figure out since it's in degrees. 360 is all the way around, but we're shy 50, so we have 310 degrees. And then if we need another negative one, we're going to go negative 360 and negative 50 more for negative 410 degrees. Now complements and supplements, they have to be acute angles. They have to be positive angles, well for complements, positive angles that add up to 90. So 75, if we add 15, it adds up to 90. You might not have had any work, but you could certainly sketch it if you wanted to. And then to add up to 180, the supplement would be 105 degrees. Degree marks were very important. For the next one, 3 pi over 5, since this is about half, it's half of 5, or 2.5 pi over 5, which isn't a good way to answer a question, but again, it's just my road map. it has already gone past 90 degrees or pi over 2, so there is not a complement. Now if I sketch 3 pi over 5, I need to add 2 pi over 5 to get 5 pi over 5, so that's its supplement. And in number 11, 4 pi over 3 is already past 180, so there is not a complement or a supplement. The bottom ones were they were ones you didn't need any work for. 150 degrees, 30 degree is the family it belongs to. There are 5 30s in 150, or 5 30s, 5 pi over 6. 45 degrees is pi over 4, and it's negative. 3 pi over 2 means 3 90s, or 270 degrees. Negative pi over 6 means negative 180 over 6, or negative 30 degrees. Okay, the back, in order to get the answers, there were a couple of problems with writing the correct decimal places, so you want to be careful. We know it's 120 degrees, so I don't have to worry about that. This is 20 minutes out of 60 and 32 seconds out of 3600. If I round to 2 places, that's going to be 0.4. This one, I want to keep the negative 37 degrees, because if I add something to negative 37 degrees, it would be negative 36 degrees, which would change our degrees. We don't want to do that. We just want to take the 33 over 60 plus 79 over 3600. And then our calculator does the next two. This is just under the angle menu, the DMS, so you're just going to put in 47.58, and it is going to give you, 47 degrees, 34 minutes, and then just round the number of seconds. And the same thing with the next one. So these were really good. Okay, for the last 3, in each case you're going to use S equal R theta. The key to this formula, however, is theta has to be in radians. So if they give me 70 degrees, it is not in radians. So I definitely need to put it in radians before I put it in the formula. So that's 7 pi over 18. So if the radius is 11 inches and the angle is 7 pi over 18, I get 77 pi over 18, and the units will be the same as the radius units. So those will be inches. If you did this on the calculator, you want to make sure you're using the pi key and you're not rounding until the very end. Okay, the next one wants to know the angle. So if I have S equal R theta, if I want to, I could just solve that formula so that I can directly get the angle. It's the radius, it's the S equal R theta. If I divide both by R, I get S equals R. Can't write that. Okay, so if S was given, which it is the arc length, which is 7 meters, over 2.5 meters. The meters will cancel. Now, we don't want to leave an answer with decimals in fractions, so just think if you would multiply by, you can multiply by 10 over 10 or 2 over 2, but the angle is going to be 14/5, you could write radians, you don't have to, or 2.8. And the last one, we want to determine the radius if the central angle is 85 degrees. Again, before I go to this formula, I can only use the formula if the angle is in radians. So I want to figure out what 85 pi over 180 is. Okay, so that's the angle. So I want to determine the radius if the arc length, so if I don't solve this and I just put it in directly, the arc length is 4 meters. I want to find the radius, and I have 17 pi over 36, because many of you did it this way. And then some of you did 4 divided by 17 pi over 36, which is correct, but our answer is a complex fraction, and we don't want to leave it a complex fraction. My units are also meters. So in the last unit, remember, we learned that when you divide, it really means you're multiplying by the reciprocal. Now you have to be really careful on the calculator because 17 pi would be in parentheses. You could leave your answer exact as 144 over 17 pi meters. If you rounded to two places, however, you'll get 2.70 meters, and you just want to be careful that you don't round